there, this is video 8.5 and it's talking about doing scale diagrams. So we're actually going to do a 1 to 500 scale diagram of this house on a lot. But before I even start drawing, I want to change all of these into the appropriate scale. And I think what we're going to do is I'll show you how to do it with proportions because it always works. And I'm thinking after we do 2 or 3, then we might be able to find a shortcut. But we do it right first, and then we'll see how it goes. So scale is equal to diagram over real. So I'm going to be a little late. I'll do it right the first time. So a proportion is one of my favorite things in math because it's super easy. I don't want to use the F word, but it's kind of like it's essentially using fractions, but they're easy to set up all the time. So when I set them up, I always write the same thing twice. Okay, so diagram over real is diagram over new. So what I know, and this should be familiar from, I don't remember what section I was doing it in. Oh, sine function. When we did the sine law, A over sine A is B over sine B. I put what I know first. So 1 over 500 is equal to, now, let's start with the biggest number here, 40 in my diagram. Oops. Now, that's what it really is. So it's 40 meters really, but I want to know what it is in my diagram. And then I'm just going to cross multiply. So 500x is equal to 1 times 40 divided by 500. Divided by 500 equals 0.08. Now, we have to be careful because that's meters. Okay. Now, I don't have a meter stick, but that's not very useful. So if we multiply it, I'm going to multiply it by 1,000. Okay, and that 1,000 is going to convert it into millimeters. So that's 80 millimeters or 8 centimeters. If I look at my ruler, my ruler is actually in millimeters. So it's going to be 80 millimeters. So that's going to be my longest amount. Let's try another one. Let's go 4.5. So diagram over real. Remember I said I was going to do it properly the first time. So it's 1 over 500. Now in my diagram, I don't know, but in real life, we'll do the 4.5. So 500x is equal to 4.5 divided by 500. Might fix that so it looks better. Divided by 500. X is equal to 4.5 divided by 500. 0.009. And then I'm going to multiply that by 1,000, change it into millimeters, so that's meters. And times, whoopsies, times 1,000, that should be like 9. All right, well, I think you can see the pattern already. Because every time I do it, the only number that's changing is going to be this one. So it looks like basically all we have to do is divide by 500. So let's make a little chart. So 40 meters. So this is real, and this is diagram. Diagram. and we had 4.5 meters, and that was 9 millimeters. I'm just summarizing what we already did. Now I'm just going to be lazy. 2 meters. So I'm going to take 2 meters and I'm going to divide it by 500 first. And then I'm going to multiply it by 1,000. And that's going to give me 4 millimeters. And 12 meters. So 12 meters divided by 500 times 1,000, 24 millimeters. You could keep doing this, but I know that you can see from just the 2 examples, that's all we're doing. So there's no reason. It's kind of like, oh, what would that word be? Kind of a conjecture, deductive reasoning. Let's see, we made some examples and we made a rule. That'd be my conjecture. Inductive reasoning. So 12 meters and 9 meters. So 9 divided by 500. 18. Oh, anybody else see a rule? 40 went to 80, 4.5 went to 9, 2. Yeah, okay. Predict with me, how many millimeters? Look at the pattern. I'm thinking 30. Well, let's see. 15 divided by 500 times 1,000. Yeah, pretty much times 2. But we changed our units. Okay, there are 1, 2, 3, 4, 5, 6, and I have 6. Oops. All right, a little bit because some students don't know. So this side is the metric side. This should be 2 little m's, just saying, because millimeters is actually in that. So each one of those little lines is a millimeter. So it does, sort of. No, it doesn't. It doesn't like to know. It's too close. Each one between those. So if there's 10 little lines, that's 10 millimeters. Okay. Also, besides it being millimeters, if you divide these by 10 and basically just ignore the zeros, that's 1 centimeter, 2 centimeters, 3 centimeters. All right. So we need to draw our lot. And the lot was 80 millimeters. So if I had to do this on an assignment or something, I would probably try and find myself some graph paper so I could make sure my corners are all square. All right, and then we have 15 meters this way, so that's 30 millimeters. Because I'm kind of guessing to make this a nice square corner. And we'll measure 30 millimeters on this side. And hopefully this comes out. Oh, I did pretty good. Actually, I did really good. It's 80. I've got a nice rectangle going on. All right. Now, this one coming in from the side. So the house is going to be over here. The 2 millimeters is 4 millimeters in. So I put my 0 there. So that's 1 before that big M. And I'm going to mark it. All right, and I'm going to draw this line light because I know it doesn't go all the way across. Hold on, that doesn't look right. That first one looks closer than the second one. Oh, yeah, because the second one I marked it at 5, not 4. Right. So that's that distance. Now I need to measure up 4.5. So the 4.5 is 9 millimeters. I don't know how far that one's going to go either right now. Oh, wait, I do. Let's see. Got 12 millimeters. Sorry, 12 meters is 24. So I could actually measure right now that this line is 24. So I need to stop right there. Okay. And I'm going to draw up the 9 millimeters. Sorry, 9 meters. That was 18 millimeters. So that would be 2 before the 20. And then this one, hopefully, still 2.4. Line went a little wacky. I think I'm off by a millimeter. Oh well. I'm drawing this by hand. I don't think this would be what you would do. Oh. That big sigh would be from Jellybean, who is quite distraught that I'm spending my time drawing this picture. All right, so there's my scale diagram. I think what I want to do, 40 meters, 15 meters, 9 meters, 2 meters, meters, and 12 meters. Okay, so there's our handy dandy scale diagram. So you can see from my diagram, we get a better idea, like this one. Move that so we can camera up. Just down a little bit for you. All right, in this one, it looks like the house and the front yard are about the same distance, like from the picture. If this is 12 meters, this looks like 12 meters. But you can see when it's drawn to scale, this is 12 meters, but there's a lot more room out front. Okay, so that's one of the things you can do with scale diagrams, is draw a lovely picture and get some idea of what stuff really looks like based on measurements that you took.